Chapter 4, Section 3, number 13. So we have x as a binomial random variable with parameters n equals 10 and p equals 1/3, or p equals 0.33333 repeating. Use the cumulative probability distribution for x that is given in Chapter 12 to construct the probability distribution of x. Okay, so here we need to go from the cumulative probability, and our cumulative probability was again our probability that x is less than or equal to some value. I'll just put t in there for the moment. So it's some value. So in this case, we need to find the probability that, let me draw that appropriately. We don't need all that stuff set up there as I'm jumping around on my screen. So we need the, let's get rid of all that. So the probability that x equals 0, probability that x equals 1, 2, etc. So, probability that x is less than or equal to 0, we can pull that one directly off the table, which is going to be 0.0173. For the probability that we are at 1, that's going to equal the probability that x is less than or equal to 2 minus, probably that x is less than or equal to 1 minus the probability that x equals 0. So this is going to be 0.1040 minus 0.0173. That would be 0.0867. And so for 2, the probability 2 is going to be, that probability that x is less than or equal to 2 minus the probability that x is less than or equal to 1. And so we look up at the table, that's 2991 minus our 0.140, 0.1040 equals 0.1951. And we'll continue that process up to the probability that for 10, so in this case, we're going to say this is the probability that x is less than or equal to 10. And if we look in the table, that's going to give us 0. So it's essentially in round off error down to 0. Now if we actually fill out that whole table for this, I've got that here, and there it is spelled out. So the probability of x at 0 was the 0.10173, which we just had up here. Then we have the probability that x equals 1 was the one we calculated here. 2 is calculated there, on out to 10. So there we have our set of calculations for our probability distribution.